Hello everyone, welcome back to my channel. In this video lecture, we will cover a new chapter of physics, that is motion in a plane. Those physical quantities which require magnitude as well as a direction for their complete representation and follows vector laws are called vectors. They are of two types, polar and axial. Scalars are those physical quantities which requires only magnitude but no direction. Then examples are distance, speed, etc. Tensors are those physical quantities which have different values in different directions at the same point. Example, moment of inertia, radius of gyrations, and etc. Different types of vectors, equal vectors. Two vectors of equal magnitude in the same directions are called equal vectors. Negative vectors, equal magnitude but in opposite direction. Zero or vector or null vector. Vectors whose magnitude is zero. Then velocity of a stationary object, etc. are examples of null vector. Unit vector, a vector having unit magnitude is called a unit vector. A unit vector in the direction of vector A is given by A cap is equal to A into A. Unit vector is unitless and dimensionless vector and represent directions only. Then orthogonal unit vectors are the unit vectors along the direction of orthogonal axis, that is x-axis, y-axis and z-axis. Then co-initial vectors having a common initial points. Collinear having equal or unequal magnitude but acting along the same or parallel lines. Coplanar vectors, vectors acting in the same plane are called coplanars. Then localized vectors are vectors whose initial point is fixed. Then non-localized or free vectors, vectors whose initial point is not fixed is called a non-localized or a free vector. Position vector, a vector representing the straight line distancing and the direction of any point or object with respect to the origin. Then addition of vector. First, the triangle law of vectors. If two vectors acting on at a point are represented in magnitude and direction with the two sides of a triangle taken in one order, then their resultant is represented by third side of the triangle taken in the opposite order. Then the resultant would be under root of a square plus b square plus 2ab cos theta. And if the resultant vector subtends an angle beta with vector a, then tan beta is equal to b sin theta upon a plus b cos theta. Then parallelogram law of vectors states that if two vectors acting at a point are represented in magnitude and direction with two adjacent sides of parallelogram drawn from a point, then the resultant is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point. Resultant will be the same, under root of a square plus b square plus 2ab cos theta. And then polygon law of vectors, it states that if number of vectors acting on particle at a time are represented in magnitude and direction by the various side of an open polygon taken in the same order, the resultant vector E is represented in magnitude and direction with the closing side of polygon taken in opposite order. In fact, polygon law of vectors is an outcome of triangle law of vectors. Then properties of vector addition, they are commutative, that is a plus b is equal to b plus a, that they are associative, and they are distributive. Then rotation of vectors, if the vectors is rotated through an angle 0 which is not an integral multiple of 2 pi, then the vector changes. If the frame of reference is rotated or translated, the given vector does not change. The component of the vector may or however change. Resolution of a vector into a rectangular components. If any vector A subtends an angle theta with x-axis, then its horizontal component ax is equal to a cos theta and vertical component ay is equal to a sin theta. Then direction cosines of a vector. If any vector A subtends angle alpha, beta and gamma with x-axis, y-axis and z-axis respectively, and its components along these axes are ax, ay and az, then cos alpha is equal to ax upon a, cos beta would be ay upon a, and cos gamma would be az upon a. Similarly, cos square alpha plus cos square beta plus cos square gamma is equals to 1. Then subtraction of vectors. Subtraction of a vector b from a vector a is defined as the addition of vector of negative b to vector a. Thus, a minus b is equal to a plus minus b. Multiplication of a vector by a real number. When a vector A is multiplied by a real number n, then its magnitude becomes n times, but the direction and units remain unchanged. By a scalar. When a vector A is multiplied by a scalar, then its magnitude becomes s times and its unit is product of units of A and s, but directions remain same as that of vector A. Scalar or dot product of two vectors. The scalar product of two vectors is equal to the product of their magnitudes and the cosine or cosine of the smaller angles between them. It is denoted by dot. Properties of scalar product: they are commutative, distributive, and scalar product of two perpendicular vectors is 0. Scalar product of two parallel vectors is equal to the product of their magnitudes, and scalar product of a vector with itself is equal to the square of its magnitude. Scalar product of orthogonal unit vectors is I cap into I cap is equal to j cap into j cap is equal to k cap into k cap, that is equal to 1. And scalar product in Cartesian coordinates is ax bx plus ay by plus az bz. Then vectors are cross product of two vectors. The vector product of two vectors is equal to the product of their magnitude and the sine of the smaller angle between them, and it is denoted by cross. The direction of unit vector n can be obtained from right hand thumb rule. If fingers of the right hand are curled from A to B through smaller angle between them, then thumb will represent the direction of the vector. The vector or the cross product of two vectors is called a vector. Properties of vector product: they are not commutative, they are distributive, and vector product of two parallel vectors is 0. Vector product of any vector with itself is 0. Then vector product of orthogonal unit vector is this: I cap into I cap is equal to j cap into j cap is equal to k cap into k cap, that is equal to 0. Vector products in Cartesian planes are ay bz minus az by I cap minus ax bz minus bx az j cap plus ax by minus ay bx into k cap. Direction of vector cross product: when C is equal to A into B, then the direction of C is at the right angle to the plane containing the vector A and B. The direction is determined by the right hand screw rule and right hand thumb rule. Right hand screw rule: rotate a right handed screw from the first vector A towards second vector B. The direction in which the right handed screw moves gives the direction of vector C. Then right hand thumb rule: curl the fingers of your right hand from A to B, then the direction of the erect thumb will be point in the direction of A into B. So this much for today's video. Hope you liked it and understood it well. Thank you for watching my video. Don't forget to like, share and comment my videos, and don't forget to subscribe my channel. Thank you.